morning, ladies and gentlemen. I'm happy to be here. Today I want to present a little bit our digital solution we call WIDE. WIDE stands for WinGD Integrated Digital Expert. Is our way to create value from main engine data. What I prepared a little bit an introduction, why Winterthur Gas and Diesel developed a digital solution. Then I will go a little bit in detail about this WIDE, what the software does. And then the core, our goal is the customer operational support, how the digital solution enhanced, improved our way to support customers. So let's get started with the intro. A few words about Winterthur Gas and Diesel. We are an engine developer, two-stroke engine developer, designer. Main engines, our main engine goes in bulker, tanker, bulk carrier, LNG carrier. In many applications, it's a single engine application. So a ship without a power, without an engine, is a ship in danger. So you can understand that the main engine, the reliability of the main engine is a key successful factor. Also, another important aspect is the OPEX, the consumption of the main engine. So for us, our mission is to provide customer with the reliable engine, efficient engine. Of course, decarbonization is our target. And our digital solution is basically based as the goal to improving the reliability and efficiency or monitoring the efficiency of the engine. So how we do it? The first step is to collect data. Collect data today is a standard, is something off the shelf. The main engine, for instance, the gas engine has 500 signals that we collect. But collecting the data is the first step, is not enough. We need to analyze this data. So we developed software to really go to extract from this data valuable information. The information goes to the prediction phase, and the predicting malfunction is where the value increase, and then ultimately, again, is our supporting the customer with the power of the data is our goal. So that's why we developed the digital solution in order to support better our customer. A little bit of the map of board of the ship. There is our main engine, and there we collect all the data from the ship, but also from the engine, but also from the ship, because they need to be correlated together in order to really abstract valuable information. So we do the so-called edge computing, the data analysis on the spot, and then we transfer onshore, goes to our cloud, where basically WinGD has access, customer has access. Customer means the ship operator, ship owner, head office, the fleet superintendent, and all see the same data that are on board. So the crew, WinGD, and the owner see the same data. Of course, if the owner allowed to do that. That is the key for the good collaboration. So in a way, we open the engine data to our customer in order to provide some analysis. Which analysis we do? In short, we do engine performance analysis, again with the goal to monitoring the engine efficiency, to avoid additional not necessary fuel consumption, for instance, and the engine components. There are two important goals. With the goal to do troubleshooting. Troubleshooting means in case the engine performance are not as should be, and in case the engine component have some malfunction, we need to troubleshoot. We need to provide customer the solution. How we do it? We create a digital twin together with actually a Greek developer, the developer here based in Athens. The software is very advanced. So the real engine is basically the data we are measuring is the engine as it is, the real engine. The model that we have developed is the digital twin, and the model is a thermodynamic model and the physical model or the engine component, so a deterministic model. Actually, we are developing also machine learning model that is also improve our digital twin. So the real data, engine as it is, the model, engine as should be, we compare. In case of there is a mismatch, we have an alarm. And this kind of way to analyze is called digital twin. And what is special in our case that, of course, the number of data that we're analyzing is very wide, very huge, but also it's very important to say that our model is calibrated to the several environmental conditions that the engine will experience. So always a reference, it doesn't matter which kind of condition the engine experiences. Then, of course, the result of this data, the software to visualize the KPI is aware anytime, anywhere. So again, this is a tool where the ship, the crew on board, the superintendent and WinGD see the same data. Today, we launched this program already in 2017. From 2018, all the engine that WinGD has delivered, has contracted actually, have our digital solution included in the scope of supply. Currently, we have 200 ships that are monitored, and 400 additional vessels will come soon. So our population of ship monitored increasing year over year. Few words about customer remote support. As I said, this is really the goal of WinGD. This slide is a little bit busy, but what I want to remark a couple of points. A ship without our wide, a ship with wide, what is the difference there? Think about you have an issue on board, the root cause analysis. Without our wide solution, and that was in the past, we need to rely to troubleshoot, to solve. We need to rely on the mail, screenshot, telephone calls. With wide, basically we speak with the customer in the language of data and analyze his data. So we have fast response to any issue. Engine performance, with wide, we have 24/7 continuous monitoring of engine performance. In case of any drift from as the engine should run, we inform directly the customer, avoiding then unnecessary additional fuel consumption. Statistical analysis, with wide, basically we collected data from the day one from the engine, and they are stored forever in our server, of course, with the customer allowance. Then remote support, remote control, today is possible. That was very interesting during the pandemic year. We shop tested the engine in China, where nobody can travel there. We shop tested the engine from Winterthur, from our headquarters, and that for us also was surprising that can run so easy. So downloading software, changing parameter, that was done in our office to an engine that was shop testing running to 100% in a factory in China. Performance report, recommendation, this is our dialogue. We have a close contact now with the customer. We can provide a report regularly and recommendation. An example how our operational support team work. We have currently we have two operational support teams and location. One is based in Winterthur, one in Korea. As soon we see a drift of some important parameter, like for example in this case, let's assume the temperature of the liner, our team goes in the software, download all the necessary data if it's necessary to go in the details, because of course the software is trained, has been developed for several cases, but in case the anomalies or the alarm is not included, the team goes in little bit in details, and then we find the solution. To give an example, what the people, the expert in our office can do, you see a lot of data, they can be correlated, they can put together, correlated with what is important for in order to analyze. So is really, we have the really timestamp with the fast data. We can monitor basically everything, and then this provides the solution. We have, for instance, the fast signal. What is very important for us, for instance, is to have the fast signal. Fast signals there are signals that are scanned with high resolution to really have advanced way to troubleshoot, and this gives to the expert all the picture, a very clear, a detailed analysis, because to troubleshoot properly, we need to go into details. Finally, what is the next steps that we actually are doing is machine learning, collecting data and having a great database of same engines in different conditions allow us to have a gold mine of data that we can train our machine learning algorithm. This is a case that we developed with our partner here in Athens. The scuffing detection is an algorithm that works now very, very, very nice. We are able to predict when some parameter go in the direction of scuffing, so we can anticipate this or do some necessary safety measure, activate some safety measure in order to avoid the damage or secondary damage. And what we are doing now, we are apply this machine learning, artificial intelligence in all the major engine components. We have the experience, we have the data, and the technology is there. So our software increase year over year of the knowledge and potentiality. So just conclude the last 30 seconds. So how wide is for saving fuel cost, give to the owner and to our customer full access of engine data. Many customers still doesn't realize how many data we collect. And by the way, we can add to our, let's say, engine database, whatever vessel performance monitoring. We have also a vessel performance monitoring agreement in order to evaluate the ship resistance. Engine failure prediction, advanced troubleshooting, the failure prediction, so anticipate the failure prediction, and the dynamic maintenance plan. That is our wide system, and that is the direction we are going. Thank you.